Let's fill in this table here about the formation of ions. We're going to use calcium, oxygen, and xenon as examples. Calcium is a metal. It's on the left-hand side of the table. Oxygen is a nonmetal. It's on the right-hand side of the table. And xenon is a noble gas. So if we drew the electron dot structure for calcium, we would see it's in family number 2. So it has 2 valence electrons. So we'd represent those 2 electrons like so. We can see by looking on our periodic table that calcium has 20 protons, an atomic number of 20, which means as a neutral atom, it will also have 20 electrons. If we draw the electron dot structure for oxygen, oxygen is in family 6, so it will have 6 valence electrons. So we'll start by putting 2 in that s orbital, and then 1 electron on each side before doubling it up. Notice I'm using X's this time instead of dots. That's also common, so you can tell the electrons from different atoms apart from each other. So, oxygen, if you look it up on the periodic table, it has 8 protons, atomic number of 8, which means it also has 8 electrons. So we know from calcium being in family number 2 that it is going to lose 2 electrons to become an ion. So calcium would end up having a 2+ charge on its ion. Along the same lines, oxygen is in family 6. Everything in family 6 is going to gain 2 electrons to become an ion. So the charge on an oxygen ion would be 2-. So the number of protons in these ions do not change. Calcium is still going to have 20 protons, but now it's lost 2 electrons. It's going to have now 18 electrons. Well, now if calcium ions have 18 electrons now, that's the same electron configuration as argon. Argon also has 18 electrons. Weird. Okay, oxygen still has 8 protons, but now it's gained 2 electrons, so it has 10 electrons. Well, oddly enough, neon also has 10 electrons. So it has the same number of electrons now as neon. Weird. When we draw the electron dots for these ions, for a cation like calcium, it gave away its 2 electrons. It doesn't have any more valence electrons to represent as dots, so you're done. The symbol, the electron dot for a cation is the same as the symbol for the cation. When you do an anion now, this has gained 2 electrons, so we're going to show that this atom has gained 2 electrons to become an ion, and that's why we're using X's, and then now the electrons I add can be the dots, so it shows you that the electrons are coming from 2 different locations. So now this oxygen atom has 2 more electrons than it should, so we know it's a 2-. So when you draw the electron dot structure for an anion, you will always show the electrons. Well, let's do xenon, this noble gas. The symbol for xenon is Xe, so when we do the electron dot, we'd fill it in with 8 electrons. And xenon has 54 protons, which means it has 54 electrons. Now, it has a full valence shell. It's not going to form an ion. We don't need to do the rest of this table.